Okay, in section 2.5, we'll talk about transformations. At this point, we should all be able to recognize the graphs of our basic functions. I've went over the basic functions worksheet. Sometimes we're asked to graph a function that almost looks like one of our basic functions. Okay, looks like one that we already know how to graph. For example, suppose that we have the square function. And here's the square function. But suppose that this is shifted down so many units. Okay, what is the new equation? Well, in order to answer that question, we need to know something about transformations. Okay, so there's three basic transformations. Four, if you want to include another one. But let's check it out. The first example, h of x equals x squared minus 4. Let's graph that one, and we'll compare it to the original, y equal x squared. So if x is 0, h is negative 4. If x is 1, h is negative 3. If x is negative 1, h is negative 3. If x is 2, h is 0. And if x is negative 2, h is 0. It looks like we shifted down 4 units. Okay, the reason why the shift down 4 units is because the minus 4 there. Okay, that's what's causing that to happen. Suppose that we have k of x equal to x squared minus 4. Then k is given by, well, let's take some values here. 0, 16. Negative 4 squared is 16. That's way up here. 1, 9. Negative 1, 25. That's way up there. 2, 4. Okay, 3, 1. 4 is 0, 5, 1, and 6, 4. So we end up getting a parabola that is shifted to the right 4 units. Why did we shift to the right 4 units? Well, it's because that minus 4 there that's causing that to happen. Here's in general what we need to know about shifting a graph. Let y equal f of x be one of the 8 basic functions. 9 if you include the greatest integer function, and c be a real number. Item 1, if y is equal to f of x plus c, like we had up here, then that means that you're going to shift the graph up if c is positive and down if c is negative, just like we're shifting down if c is negative. If c is positive, y equals f of x plus c, then you're going to be going to the right if c is negative, and you're going to go to the left if c is positive. Now it's kind of backwards from how we'd want to think of it. Usually we think c positive, I go to the right. C negative, I go to the left. Okay, but it's switched on us. Okay, c positive means that you go to the left that many units. Okay. And of course, c being 0 means that you've done nothing to change the original graph, so you're shifting at 0 units. Okay. Here's an example. Suppose we have f of x equal x plus 4 squared minus x plus 3 squared minus 4. Then, if we know that we're graphing something related to y equal x squared. The minus 3, x minus negative 3, means that I'm shifting to the left 3 units. And the minus 4 means I'm shifting down 4 units. So the vertex is at negative 3, negative 4. Okay, and I've found the intercepts as well. Okay. Another example is h of x equals negative x. So the domain of h is all real numbers that are positive, non-negative, I should say. 0 is included. So if x is 0, h of 0 is 0. 0, 0 is on the graph. If x is 1, h of 1 is negative 1. If x is 4, you get negative 2. And if x is 9, you get negative 3. Okay? So it looks like we shifted the reflected the graph about the x-axis. K of x equals negative the square root of x is has domain all non-positive numbers. 0 is okay. If x is 0, square root of 0 is 0. If x is negative 1, negative the quantity negative 1 is 1, and the square root of 1 is 1. If x is negative 4, negative the quantity negative 4 means I get 4, and the square root of 4 is 2. Okay, and if x is negative 9, negative the quantity negative 9 gives me 3. Okay, and that should be a negative there. Sorry about that. So I end up getting a half of a parabola kicked on its side, facing outward towards the left. Okay, and here's what we have to know about this type of transformation. Let's let f be given, and y equals negative f of x means that I want to reflect f about the x-axis. Y equals f of negative x means that I reflect about the y-axis. So here's an example. Suppose I have f of x equals negative the quantity, the square root of negative x. Well, the negatives don't cancel out, right? That would be a mistake. But I'm going to have two reflections. One about the x-axis, because the negative that's in front, and then the negative that's underneath means I'm going to go about the y-axis. So I'll be reflecting about both the axes, and I'm going to be in quadrant 4 then. Okay. Here's one. H of x is equal to 2 times the absolute value of x, and k of x is equal to 1/2 times the absolute value of x. I'm going to go ahead and graph h and k on the same graph, just so that we can compare more easily. And I'm going to graph f of x equals the absolute value of x on the original graph also. So if x is 0, I get 0. If x is 1, I get 1. If x is negative 1, absolute value of negative 1 is positive 1. So negative 1, 1 is on the graph. If x is 2, I get 2. And if x is negative 2, absolute value of negative 2 is 2. Okay. So, and I'm going to use these same values in a chart when I graph h and k. If x is 0, h is 0. 2 times 0 is 0. If x is 1, 2 times 1 is 2. If x is negative 1, absolute value of negative 1 is 1. 2 times 1 is 2. If x is 2, 2 times 2 is 4. And if x is negative 2, absolute value of negative 2 is positive 2. 2 times 2 is 4. Okay, so I end up getting this graph here. And if k of x is equal to 1/2 times the absolute value of x, I end up getting a different curve. If x is 0, and 1/2 times 0 is 0. If x is 1, 1/2 times 1 is 1/2. If x is -1, absolute value of -1 is 1. 1/2 times 1 is 1, is 1/2. If x is 2, 1/2 times 2 is 1. And if x is -2, absolute value of -2 is 2. 1/2 times 2 is 1. Okay, so I end up getting a graph that's still V-shaped, but been smashed. Okay, and one way to remember this definition is with the vertical stretching and compressing is let y equal f of x and c be a real number, any real number we want. Okay, if you're in the form y equals c times f of x, you're going to have a vertical stretch if c is greater than 1, and you're going to have vertical compression if c is greater than 0 but less than 1. Now, in order to get the new graph, okay, you're going to multiply the y values by c. Okay, so check it out. If I get 0, 0, I multiply the y value 0 by 0. That doesn't change anything. But here's 1, 1. Okay, multiply the y value by 2, and that puts me at 1, 2. Here's -1, 1. Multiply the y value by 2, that puts me at -1, 2. Okay, here's 1, 2. 2, 2. Multiply the y value by 2, that puts me at 2, 4. And here's -2, 2. Multiply the y value by 4, that puts me at -2, 4. Okay, same thing on this graph, k of x. Only I'm going to multiply by -1/2. So if x is 0, I get 0. That doesn't change anything. I'm still at 0, 0. If x is 1, 1/2, 1 is on the graph. Excuse me, if x is 1, 1/2 is on the graph. Now, in order to get that, 1, 1 changed from 1 to 1/2. Okay, if x is at -1, -1, 1 goes from -1, 1/2, which is right here. If x is at 2, 2, 1/2, 2 goes to 1/2, 1, and that brings me to this point. And if x is -2, then 1/2 negative, 1/2 positive 1 is on the graph. 1/2 positive 1. So I end up basically multiplying all the y values by this number c to get the new graph. Okay, if c is 0, well, let's take a look. If c is 1, then I've done nothing to change the original graph. Okay, if since I'm just multiplying by 1. If c is 0, I got y equals 0. Y equals 0, that's a horizontal line at a height of 0. Okay, and I'm not doing anything with that. If c is negative, I get a reflection about the x-axis. And so the thing with this is that sometimes you can end up with a vertical stretch and compression that's also a reflection. Okay, if c is negative, we get a something that would be down here. Okay. We also have on the next page horizontal stretching and compressing. can. I'll talk about that later. But let me stop right there, and we'll get back to this in the next video.